Hello students. So today we are going to discuss one or two problems related to Euler-Cauchy equation or homogeneous linear differential equation. Okay. So take down the problem. Solve x cube into d cube y by dx cube plus 2x square into d square y by dx square plus 2 into y is equal to 10 into x plus 1 by x. Okay. So once you observe this equation given, so it is in the form of Euler-Cauchy equation, right? So just follow the steps to solve that. So what we need to do here, we need to put x is equal to e power z. Okay. So by putting x equal to e power z, we get z is equal to log x. Okay. And let d is equal to d by dx. Okay. And also we go on substituting x into d by dx is equal to d x square into d square by dx square as d square, that is d into d minus 1. Okay, d into, so d minus 1. So then x cube into d cube by dx cube as d into d minus 1 into d minus 2, thereby putting these values in the given equations. The given equation reduces to d into d minus 1 into d minus 2 plus 2 into d minus 1. Okay, so plus 2 of y, that is equal to, we need to write the right hand side material, and here x is to be replaced with e power z and 1 by x is written as e power minus z. Okay, so now I try to simplify the LHS. By simplification, we are going to get d cube minus d square plus 2 of y is equal to 10 into e power z plus e to the power of minus z. So if you observe this equation clearly, this is a linear differential equation with constant coefficient, and here y is the function of z. Okay, so as usual, find the complementary function and particular integral. Okay, so for finding complementary function, we need to write the auxiliary equation. What is the auxiliary equation here? We take m cube minus m square plus 2 equal to 0. Okay, so this can be taken as, and if you observe this equation carefully, by trial and error method, we can say 1 is the root of this. Okay, that is minus 1, right? By putting minus 1, we can satisfy this equation, right? So therefore by putting m equal to minus 1, we are going to get 0 here, that becomes minus 1. Okay, minus 1 plus 2 equal to 0. This implies m equal to minus 1 is a root. Okay, by trial and error method, we need to get one root. On dividing the given equation m cube minus m square plus 2 by the factor m plus 1, we are going to get m plus 1 into m square minus 2m plus 2 equal to 0. And now by solving m square minus 2m plus 2 equal to 0, we get m equal to 2 plus or minus square root of 4 minus 8 divided by 2. So this is giving us 1 plus or minus I. Therefore the roots are one root is real and two more roots are imaginary. So what is the complementary function? The complementary function is y is equal to c1 into e to the power of minus z plus e to the power of z into c2 into cos z plus c3 into sin z. Okay, and we can write z as log x. Okay, so let us call this equation 1. Okay, now we go for finding the particular integral. So what is the particular integral? So this is definitely resembles the first case of pi where the right hand side is exponential. There we need to replace d by a, d square by a square, etc. Okay, so let us see that. So for finding pi we write 1 by f of d. What is there in f of d? D cube minus d square plus 2, okay, of 10 into e power z plus e power minus z. Okay, so now we split into 2, that is 10 into 1 upon d cube minus d square plus 2 into e power z plus 1 upon d cube minus d square plus 2 into e to the power of minus z. Okay, so let us solve these two. In the first term we need to replace d by a where a is 1, and in the second case we have to replace d by a where a is minus 1. Okay, so now this is giving us 10 into, okay, so that is e power z upon 1 minus 1 plus 2, and from the second term if I replace d by a where a is minus 1, we are going to get minus 1 minus 1. Okay, that becomes minus 2 plus 2, we will get 0. Okay, so to overcome that we need to multiply by the independent variable, that is z, into 1 upon 3d square, differentiate the denominator with respect to d as before, minus 2d of e to the power of minus z. So this is giving us 10 into, and here you can cancel plus 1 minus 1, we get e power z upon 2, okay, plus z into, now we can replace the value of d by a where a is minus 1, that is z into e power minus z upon 3 into minus 1 whole square minus 2 into minus 1. Okay, so that is 3 plus 2 5. Okay, so we write here 3 plus 2 5. Okay, so this is the value of pi we get. So once we get pi, as usual, to get the complete solution, add pi to the complementary function. So we write complete solution is equal to complementary function plus particular integral. After writing that, we need to mention where z is equal to log x. Okay, yeah, so using the same technique, I am giving you some problems, 2 to 3 problems. Please try them using the same technique. Yeah, solve x cube into d cube y by dx cube plus 3x square into d square y by dx square plus x into dy by dx plus y is equal to x plus log x. This is the first problem we need to try, and one more problem is here. Solve x square d square y by dx square minus 3x into dy by dx plus 5 into y is equal to x square into sine of log x. Okay, so try to solve these two problems using the same technique.